Okay, so we've got a radioactive sample, typical application that you saw in your homework, okay? A radioactive sample of, am I getting blurry or is it the camera? Am I blurry? No, I don't look blurry. But on the camera, okay, it must be the camera. Okay. I mean, sometimes I get blurry, you know. Okay, well. Okay, no, the camera's, geez, every time I walk in, things get blurry. Are you sure? Okay, well, I'm gonna assume I'm not blurry. Okay, you have a radioactive sample. It's embarrassing doing blurry. Okay, you have a radioactive sample. Standard application. Okay, and it's 50 grams today, and it was 70 grams. And days ago. I'm putting a little twist in this because it's usually not stated quite this way, okay? So I'm going to say, if t equals 0 10 days ago, what is A of t, the amount at time t, where t is in days? Okay. Let's see if we get a start on this. And I will, right now, I'm going to give a hint in a few minutes, but right now, first thing you need to understand is A of t is an exponential function. There's a reason for that I'll talk about when we get into solving it. But you can start with the idea that A of t is an exponential function. And I'll even say it, that's because the rate at which the amount changes is proportional to how much you've got. The more you've got, the more you're going to lose in a given time. A lot of you are quoting a formula that you remember correctly. Okay, I think it's correct. But those formulas are a little more complicated than just understanding what an exponential function is. Okay. Okay, I'm going to change my function name. A stood for amount. But a lot of you are using T as a population function because that's the first thing you saw And there's really nothing wrong with doing that. Okay. Now, the letter P doesn't have a lot to do with the amount of radioactive material, but that's okay. We call it P of T, okay? Since you like P of T. Okay, so y, an exponential function has the form y equals a b to the t. Or another standard form is y equals a e to the kt. You have the tools at this point to deal with either, but let's go ahead and use this because it's going to be simple in this case. Okay, so this general form of an exponential, which is just the b to the t function vertically stretched by factor a, which relates back very closely to our basic functions. Okay, could be written this way. Now, there are a couple of other forms. People have other forms written in their paper, like something very much like this, but they have that's one p naught times 1 plus k to the t. I would usually write that 1 plus r to the t, because r is your rate of change. Okay, and I'm kind of thinking I saw r instead of k, but if k's in there, that's okay. It doesn't really matter what that letter is. Okay, and I'm going to write it as 1 plus r to the t. And you might have seen the terminology that 1 plus r is called your growth factor and r is your rate. Okay, so you have this possibility. Now, one way or another, you can take this form, you take this form, you take any form. Okay, but now put your information, pick a form and put your information into it. Now, some of you have written an equation involving logs, and that's okay, except that that equation is a little more complicated than this one, and this one will serve perfectly well. Okay, so you might think about using this one. You're not likely to remember the other one. Okay, I'm seeing a lot of different ways to do this. Okay. Comes down to this. T equals 0, T is 70. Okay. T equals 10. If T is 50. Okay. We have this equation. Okay, so if T is 0, P of T is 50. Well, so leave myself room. We could write P of 0 is 70. Okay. And let me rewrite that. Leave myself enough space. Okay, so let me write it again. When When t is 0, P of t is 70. Well, if t is 0, then P of t is just P of 0. So we can write P of 0 is 70, okay? So we got P of 10 is 50. That's what our information tells us. When t is 0, the amount is 70 grams, okay? Because t is 0 10 days ago. Then 10 days later is today. That's when t is 10. So when t is 10, then P of t is 50. Okay, well, P of 0 is 70. So P of t has this form. I need more room to write that out. Okay. Let's start off here on this board. Okay, so what we have. I'm just using the b to the t form, okay? Now, if you want to use the 1 plus r to the t form, that's fine. Instead of writing b here, you write 1 plus r. It's really simpler if I just write b. Let's write it this way. So P of 0 is P naught times b to the 0, right? P of 0 is equal to 70. So =70 equals P naught b to the 0. Okay, P of 10 is P naught times b to the 10. And of course, we've seen that P of 10 is 50. Came on after 10 days. So 50 equals P naught b to the 10. So now we have the system of equations. Is this. And this. We need to solve for P naught and B. Okay, so what can you do with this first equation? Let's call this equation 1. Call this equation 2. Equation 1 tells us that P naught times b to the 0 equals 70. What's b to the 0? What's any number to the 0? It's 1. Well, that's easy. P naught has to be 70. So if you know the quantity at time 0, you can easily enough solve for P naught. Okay? Now you got P naught b to the 10 equals 50, but we know that P naught is 70. Now you can solve that for B. So you can solve that equation for B. Okay. Well, people did pretty well with the first step of this. You divide both sides by 70. So that b to the 10th is 5/7. How do you solve this? You don't divide by 10, 10's up in the exponent. Okay. You could change it to logarithmic equation, but that wouldn't do you any good. So what you do is if you raise b to the 10th to the 1/10, then of course you got to raise the other side to the 1/10th power. Okay. Now b to the 10th to the 1/10 by the rules of exponents. And I'll write that down over here. Power of a power, you multiply exponents. You multiply the exponents, 10 times 1/10 is 1. I think somebody got something in the order of like 0.96. Okay. So a couple of 0.03s there, which doesn't make a lot of sense because 0.03 raised to the 10th power is a really tiny number. Okay. So that's one way to solve it. Now, the other way to write this out, which would have been okay. Is to write the 10th root of b to the 10th. Tenth root of 5/7. And that's round, might round off to 9/7, but I think it's 9/6 something. I believe what I saw. Okay. Well, that's good, but you got to know how to solve it. Equation like b to the 10th equals something. Okay. And I prefer the exponential form because it's more obvious that the rules of exponents apply here. How do the rules of exponents apply here? It's like you got to know something else to be able to do that. So I would stick with the rules of exponents unless you're very certain about the radicals. And the way to understand the rules for radicals is to understand how the exponents work. Okay, so everything comes back to exponents. Now, another way of posing this problem is to say this. Here's P, the amount you have, okay? didn't say y equals p to the 2 if you want, but then you got p in here. So you got 70. So let's just say that here's 80. So we can subdivide that down to 40, subdivide that down to 20, and we can kind of mark off on 10. We put 60 here. We mark off the 10 in between. There's a scale that shows us on a graph what's happening. Since this whole course has been approached in context of graphs, if you want to solve this equation in a way that makes as much sense as possible, you don't just do the algebra because you're going to forget the algebra. Okay? You're going to be likely to forget the algebra. You say this. Okay. Here's a point on our graph. That's the point. 0, 70. When t equals 0, p is 70. So immediately our information here gets put on the graph before we ever worry about the form of the function. Okay? Then, well, what's our other information? After 10 days later than t equals 0, we have 50 grams. So that means that when t is 10, the amount is 50. And we have an exponential function. This thing is kind of concave up. A slightly different graph. I'll use a different scale. It's more obvious how concave it is. I put 10 here and 70 here. Well, 50 is going to be about here. Without going into a lot of detail on the scale, this is going to fall off something like this. Okay. This function is exponential function. In your text and everywhere else, the most general exponential function you have is a b to the t. Okay. Well, p of t equals p naught b to the t is of the form a b to the t. You're using p naught instead of a, but it just articulates completely with the idea of a vertically stretched b to the t function. If you understand it at that level, then you've got a picture to go with the algebra. You're going to understand it much better and be more likely to get it right. Okay? If you just memorize an algebraic formula or something involving a natural log and an h and stuff like that, you're not basing it on what I hope is the solid basis of these graphs and these basic functions. You've just got a formula and you're using that formula without really understanding it. You can do this with understanding. So I advocate this way of doing it. I think you're going to understand it better. I think you're going to be more likely to be able to do it in the exam in a couple of weeks. Okay? Do what works for you. If you're good at memorizing formulas and have to use them, okay. But it's not going to prepare you as well for subsequent courses if all you do is memorize formulas. Okay, try to understand it as deeply as possible. Bottom line, we'll make a grade in this course, do what gets the grade. If you can memorize a formula and use it, I don't think it's the best way to learn. But if it gets a job done, I'm certainly going to accept it. Okay? Okay. Let's go on with what we can answer about this function. So P of t is about 70 times 0.96 to the t. What's the half-life? Where you see the half-life on the graph? What's half-life mean? Half-life means how long does it take it to fall to half? Well, this is a particularly well-drawn exponential function, but we'll use it anyway. And we'll estimate. I always advocate you draw a graph and you estimate, then you do the algebra. If you do, you understand the algebra better and you're more likely to set up the problem correctly. So half of 70 is 35. So let's just see approximately on this graph. Okay, halfway, 35 might be about here. So this curve indicates that you hit 35 about here. Well, what do you estimate t is? Write down in your paper. Okay. Sketch a quick graph here and estimate what this t is. Okay, so everybody got the same estimate. They got 15. I thought it was 14. I don't know what's the matter with you people. You got 15. Okay. Class estimate 15. I'll even put that down with a question mark. So graph estimate's 15 days. Let's see how that works. You got calculators. Plug it in. We've got our function. Okay, well, there's our function, right? Now, Montana, you got 0.96 what?
I got 0.9669125.
Okay, so
830.
yeah, well, we're going to make it 0.967 just to see. Okay, because that will affect our half-life. Okay. So what we're checking is p to the 15 equals to 35. I'd say it's going to be reasonably close. It's probably going to be within, some between 30 and 40 for sure, but it's going to be somewhat closer than that. It could be. I think it's going to be a little less than 35. That's because of the way I'm looking at the graph. I don't look at the graph that well. Okay, I said, well, I thought it was going to be a little less than 35 because of the stupid way I drew the graph. Okay, and the way I was looking at it. Notice that graph has a little crook in it there. And maybe, I don't know. But I didn't draw a great graph. It's never happened before, so don't be shocked. So either I didn't draw a great graph, or everybody's calculators are malfunctioning. Okay, another virus, calculator virus. It's obviously it. Okay, well, okay. Of course, that was your estimate. Your estimate was, my estimate was 14. That would have been even worse. Well, let's find out what the heck it is. We're apparently, you guys can't estimate from a professionally drawn graph. Okay. Well, let's solve. Well, that would be 70 times 0.967 to the t equals 35. Okay. So you can solve that. You have all the techniques you need to solve that. So let's see what you do. Okay. So here we have this equation. Okay, so we're going to divide both sides by 70 because the t we're trying to solve for is in the exponent. We got to get this into the form b to the a equals c. Okay. So we can change it to logarithmic form, right? it's not in that form because that's 70 there. Of course, we saw that, we looked at that. And I think you had to use that to solve some of the equations that were signed. Okay, so anyhow, make sure you understand that. So you divide by 70.
Okay.
And once you do that, you get an equation you can easily solve. This gives you 0.967 to the t equals 1/2. Because 35 over 70 is 1/2. The reason we use 35 is it's half of 70. So now how do we solve that equation? We change it to logarithmic form. And it's something you've done a number of times. Right there we have it. We can identify our A, our B, and our C. Here's our B, here's our A, here's our C. This gives us the form log base 0.967 of 1/2 equals t. So the t is the log of 1/2 divided by the log of 0.967. Okay, that should be familiar to you. You might have lost track of it in all the booming, buzzing confusion, but there it is. So what do you get? Log of 1/2 over log of 0.967. So 20 makes a certain amount of sense. It falls from 70 to 50 in 10, right? Then it falls from 50 to 35 in another 10. So that means it goes down 20 and it goes down 15. Well, that's kind of what an exponential function would do. Okay. Well, there are a lot of techniques in here that you probably want to practice a little more. And they're consistent with the techniques that the text uses. The open math. I will say that sometimes open math uses different forms. So this could, if you did this for U of t equals t naught times 1 plus r to the t. Well, instead of b, you have 1 plus r. Okay. You get the equation. So instead of these two equations, okay. P of 0 would be this, which would be 70, right? P of 10 would be this, which would be 50. So there are two equations. And the only difference between these two equations and these two equations is I'm using b instead of 1 plus r. Okay, well, this leads you to p naught equals 70 and 1 plus r to the 10th equals 5/7. 50 over 70, and that's 5/7. Okay, and you get one plus r equals this. So you get r. Okay, and this equals We could easily solve that for R. So the whole solution process is identical to this, except that instead of B, we're writing 1 plus R. Now, we could solve it just using B, and then we said, well, B is 1 plus R. Okay, so if we want to find R, we could find it. R is your rate. It's like you're losing 3% per day, 3.3% per day. Approximately. Okay, or it could be your equations could end up could use the form P naught e to the KT. That would give you well, when T is 0, P is 70, right? When T is 10, P of T is 50. And we solve this. Okay, and we would get P naught is 70 because, of course, e to the 0 is 1 and P naught is 70, just same as it was before. Here, you're going to get e to the 10k equals 5/7. And you take the natural log because you have the base e. So you have a natural log button in your calculator and you get here's a natural log of 5/7 divided by 10. And then you have your model for an e to the KT. All right. Now there are other relationships within this, but to get that much down, and it's pretty much okay. All right. We need to switch gears and talk a little bit about solving 2 simultaneous equations and 2 unknowns. Which is pretty straightforward, but we want to get off to the right start. So that when we get to 3 equations and 3 unknowns, it's slightly more complicated. Then we'll talk about that Tuesday, and you'll have it down by Thursday. Okay. Of course, Thursday's the end of the course. So I'm going to actually divide this into 2 recordings.